In today's lesson, we're going to look at simplifying nth roots. We've done some of this before, but today we're going to delve more into the rationalization of these, which gets a little more difficult. So let's start out with something we've kind of done before. Up to this point, we've done perfect nth roots. Now, in our first case, this is exactly what we have. We have a perfect nth root of 32. What multiplied by itself 5 times gives me 32, and we know that's just 2. So in this case, we can simply say my answer is 2. However, in this case, what multiplied by itself 3 times gets me 81, no such deal. So what we have to do is we have to simplify this like we did with square roots by finding our biggest perfect cube in 81. Now when I look at my perfect cubes, we're going to look at 1. Perfect cube related to 2 is 8. Related to 3 is 27. Related to 4 is 64, etc., etc. So we want to use these numbers to try to divide those into 81. I know 27 goes into 81, and that goes in 3 times. So what's the cube root of 27? That's 3 cube roots of 3, and that's my simplified term. Always use the biggest perfect cube. So let's do a couple more, except in this case we're also going to add in our variable terms. Biggest perfect cube in 32 is an 8. And then I have the cube root of 4 left. What multiplied by itself 3 times goes into 13 as far as variables go? Well, I know a perfect cube in that would be x to the 12th. That leaves me with the cube root of x left. And then a perfect cube in y to the 8th is y to the 6th, and that leaves me with y squared. So let's break all these down. I have a 2 here. What multiplied by itself 3 times gets me x to the 12th, that's x to the 4th. What multiplied by itself 3 times gets me y to the 6th, that's y squared. And then my remaining cube roots are 4, x, and y squared. And then we're done. Same thing for 162, except now we're going to perfect fourths. So the perfect fourth of 1 is 1. The perfect fourth of 2 is 16. The perfect fourth of 3 is 81, and that's going to be my guy. So I'm going to say, if I take the 4th root of 81 times the 4th root of 2, I get 162. I need a perfect fourth that goes into x to the 23rd. That's going to be x to the 20th, leaving me with x to the 3rd. And then the perfect fourth in x to the 9th is x to the 8th, leaving me with the 4th root of x. Or I'm sorry, y. Those are y's. So 4th root of 81 we said is 2. 4th root of x to the 20th, what multiplied by itself 4 times gets me x to the 20th, that's x to the 5th. What multiplied by itself 4 times gets me x, or y to the 8th, that's y squared. And then list my remaining perfect fourths. That's a 2, an x cubed, and a y. Now let's talk rationalization. Can't have radicals in the denominator, and then we have to rationalize by a form of 1 to get rid of those. The thing we're going to have to concentrate on this time, though, is we need a perfect cube in order to get rid of the radical. So let's keep that in mind. First thing I'm going to do is break these down if I have any perfect cubes in my problem, which I do. So in the numerator I have the cube root of a cubed and the cube root of a squared. B is the cube root of b cubed. And then in the denominator, I have the cube root of c squared. So simplifying that a little bit more, I have a, b, cube roots of a squared all over the cube root of c squared. Now, I need a perfect cube in order to get rid of this squared term. So, in this case, c cubed is the first perfect cube I can think of. So in order to make a c squared into a c cubed, I need to multiply by the cubed root of c. So you'll notice now that in the numerator I have a, b, cubed root of a squared c. In the denominator, I have the cube root of c cubed, and that is c. So I'm done. Let's move to the next example. Are there any perfect cubes in the numerator? Sure. We have the cubed root of y cubed times the cube root of y and the cubed root of 9. The denominator, no perfect cubes. And I'm going to separate these individually just to illustrate a point. Cube root of y squared is y. What's left is the cubed root of 9 and a y. And in the denominator, I have the cubed root of 2 and the cubed root of x. Now once again, I have to rationalize by a term that's going to get me a perfect cube in the denominator. Now the first perfect cube that I can think of that involves a 2 is 8. So I need to make that 2 and 8 by multiplying. So I better multiply by 4. Cube root of 4 times cube root of 2 is the cube root of 8, which is going to be a perfect cube. The first perfect cube dealing with an x is x cubed. So x times what is x cubed? That's x squared. And that's what I'm going to rationalize by. The cubed root of 4 times the cubed root of x squared over itself. And that's multiplying by 1, so I'm not changing any values. So now you'll notice, multiplying across, I have y cube roots of 36 x squared y over the cubed root of 8x cubed. There are no perfect cubes in 36. There's perfect squares, but not perfect cubes. And there are no perfect cubes in x squared and y. So I just have 36x squared y in the numerator. And in the denominator, that's a perfect cube of 2x. And I'm done. Let's do one more just for practice. And this has perfect force. So let's go over here and look at our force. We have perfect fourth for 1 is, once again, 1. Perfect fourth for 2 is 16. Perfect fourth for 3 is 81. And that ought to do it for trying to break these down. So within 32, I have a perfect fourth of 16. So I'm going to break this down to the fourth root of 16 and the fourth root of 2. And then something multiplied by itself 4 times is going to get me z to the 22nd. That's going to be a z to the 20th and the fourth root of z squared over, I'm going to split all these up just like I did in my last example. Fourth root of 27, fourth root of x squared, and fourth root of y cubed. Now I need perfect force to be able to get these out of the radicals. So my first perfect fourth dealing with the number is 81. To get 27 to an 81, I need to multiply by a 3. To get x squared to a perfect fourth, I need to get that to an x to the fourth. So that's multiplying by another x squared. To get y cubed to a perfect fourth, I need y to the fourth, so I must multiply that by y. And then, as in all cases, when we rationalize, we need to rationalize by a form of 1. So let's go ahead and do that. And in this case, I'll start pulling all my perfect fourths out. Fourth root of 16 is 2. Fourth root of z to the 20th is z to the 5th. None of these are perfect fourths, so I multiply what's left. That's the fourth root of 2 times 3, which is 6. Use my x term first, my y term second, and my remaining z term over. This bottom term should be a perfect fourth when I multiply it all together. There's an 81, there's an x to the fourth, and a y to the fourth. So this simplifies into 2 z to the 5th, fourth root 6 x squared y z squared over fourth root of 81, as we said, is 3. Fourth root of x to the fourth is x, and y to the fourth is y. And we're done. That's all we've got. Make sure you do your Connect Ed and fill out your survey. We'll see you tomorrow.